This is the first video for Chapter 7. First, we're going to talk about statistical inference, and the purpose of statistical inference is to obtain information about a population from information that we get from a sample. And remember, we talked in Chapter 1 about the difference between a population and a sample. Population is all of the elements that we're interested in, and a sample is a subset of that. The results of our sample, which are statistics, are going to provide estimates of the values of the population characteristics, which are parameters. A point estimate is just a single value, or 1 point, that's used to approximate or estimate a population parameter. If we use the correct type of sampling methods, then our sample results can provide good estimates of the population characteristics. For this course, proper sampling methods means using simple random sampling. A simple random sample has to have a certain size, so a simple random sample of size n from a population of size capital N is a sample that's selected so that each possible sample of that size has the same chance of being selected. Now a little bit more about point estimation. In point estimation, we use results from the sample to find a value for the sample statistic, and that sample statistic serves as an estimate of a population parameter. So here's some important differences in the notation. X bar is the sample mean. That's going to be a point estimator of the population mean, which we use the symbol mu for that. S, which is the sample standard deviation, is going to be the point estimator of the population standard deviation, which is sigma. And P bar, which is the sample proportion, is the point estimator for the population proportion P. Now, if we're going to use point estimates to estimate population parameters, we want to use estimates that are unbiased, that in other words will give us a good estimate for our population parameter. And some of the ones that are good estimators or unbiased estimators are means, variances, and proportions. Some estimators that aren't so good, in other words they're biased, are medians, ranges, and standard deviations. So these three do not target the population parameter very well. There's one exception to this though. The bias that the standard deviation has is really small in larger samples. You'll see a lot of cases where we do use our sample standard deviation to estimate our population standard deviation. Here's an example. St. Andrews College receives 900 applications each year from prospective students. The application form that they fill out contains a variety of information, including the individual's SAT score and whether or not the individual desires on-campus housing. The Director of Admissions needs estimates for the average SAT score for the 900 applicants and for the proportion of those applicants that want to live on campus. However, the data from the applications has not yet been entered in the college's database. So the admissions director decides to look at a sample of 30 applicants and use that to estimate these population parameters. In order to do this, she has to use simple random sampling. She collects a simple random sample of 30 applicants and uses it to calculate the following statistics. The sample mean for the SAT scores is X bar equals 997. The sample standard deviation for the SAT scores is S equals 75.2. And the sample proportion of applicants that want to live on campus is P bar, which is 21 over 30, and that turns out to be 0.70. So these three are point estimates of the population mean, the population standard deviation, and the population proportion. An important thing to remember is that if the director went back and selected another sample of size 30, she would get different results for these three statistics.